Hi, we're going to go over our notes here. This is called scientific notation, and this X stands for multiplication. I know we usually use the dot, but in scientific notation, we use the multiplication symbol. The number out here needs to be greater than 1 or equal to 1, but less than 10. So it could be 1 up to 9.9 for this number right here. And then a negative exponent represents a small number, and a positive exponent represents a very large number. A negative exponent doesn't represent a negative number. It represents a small number. And we went over why to that a little bit in class, because if you remember that 10 to the negative 2 means 1/100th of something. So when you multiply something by 100th, it's going to get smaller. 10 to the negative 1 means 1/10 of something. A negative exponent creates that reciprocal, and when you multiply by a number less than 1, it gets smaller. Calculators use scientific notation. Some of them actually use the times 10. Mine uses the times 10, but some don't. So if your calculator says this for an answer, that just means 5.3 times 10 to the negative 9. The exponent on the base 10 is a negative 9. So this E stands for the times 10. So when we're writing these in scientific notation, we are really just counting up decimal movements. We want to move the decimals so that there's only one digit in front of the decimal point. So I would move it here because I need only one digit in front of the decimal point. 4.23 is between 1 and 10. And then I'm going to put times 10. And then this power represents how many times I move the decimal point over, which was 7. The next one here, I'm moving it from here to there in between the 3 and the 9. 3.9 is bigger than 1, but less than 10. And then how many times did I move that decimal point? 4 times. So 3.9 times this number would get you back here. Okay. All that is saying what multiplication power would get me back here. So this is my answer, but if you think of it as 3.9 times 1, 2, 3, 4 zeros, okay? 3.9 times 10,000 would get you back here. All it is multiplying. Now notice this is a small number, so we're going to have a negative power this time. Small number, negative power. And I'm going to move the decimal point there. 4 is bigger than 1, but less than 10. And I moved it 1, 2, 3, 4 times. Okay, this is my answer for scientific notation, but why it's that? This is 1 over 1/10,000th of 4 would be this number right here. But counting the decimal points is faster. Just kind of looking ahead down here, like these are all not written correctly in scientific notation. We're not going to spend a whole lot of time this year rewriting them because of COVID. But this one is not in scientific notation because 53 is too big. It should be 5.3, and then that would make the power 1 up. You just need to know that this is too big. We are going to be skipping these 3 lessons this year, 8 through 15, because of COVID. This one right here is too big as well. So that's 5.37. And then this power needs to get 1 bigger. Okay. All you need to know is this is wrong because this is too big. This one right here is too small. And I would subtract 3 from that. And then this one right here is too small. And so that is actually that number there. Just realized this one was too small. This one was too small, too big, too big. Okay. Now just going back the other direction, I'm going over back of both of the lessons today. This one, rewrite each in standard form. You would move the decimal over 4 times. This means 3.97 times this number. Okay, and when you multiply by that many zeros, you just move the decimal over that many times. Okay. And that's my answer. Normally, I won't spend the time writing this middle step out. I'll just move the decimal to the right 4 times because this is going to be a big number. This one here is going to be a small number. This means 3.97 times 1 over 10,000, which when I multiply it by 1/10,000th, it's going to get a lot smaller. So I'm going to move this decimal to the left because I'm making it smaller 4 times. So my answer is 0.000397. I'm going to stop doing the in-between step. This is a big number. And so I'm going to move it over 1, 2, 3, 4, 5, 6. Add 6 zeros. It's not always 6 zeros. It's just 6 zeros here because this had no decimal points. So that's a fancy way of saying negative 7 million. It's a very big negative number. And then this one here is 7. And then here's my decimal point. I'm going to move it to the opposite direction 4 times. So maybe 0.0007. Maybe I want another 0 out there. And that's all we're going to do for this year. This is 2 lessons that I've gone over here today. We'll be practicing this again on Tuesday.